I don't know if you've noticed this or not, but in every math class it seems like we always start out by defining a bunch of stuff. We also don't let kids out early. But this is a video, so it turns out that it's an extremely useful and efficient method for getting the information to you so we can be communicating on the same level. So let's talk definitions. Welcome to the Intro to Stats 5-minute lecture series. In this series, we're covering non-calculus-based college-level statistics. It is designed around practical applications where you'll learn by doing rather than reading long, boring books and listening to long, boring lectures. So now you know the goal of these videos. It's 5 minutes, so let's try to keep it under that. Now, mathematicians have overloaded the term statistics, so sometimes folks can get a little confused. So here it is. Statistics is 1, the science of dealing with data, and 2, the facts or summaries from the data, more specifically from the sample. Notice the word sample in the second definition. Let's unravel this slightly. A population is a set of similar items or events which is of interest for some question or experiment. A sample is a set of data collected from a population by a defined procedure where the procedure is usually random. Notice the mention of a question or experiment at the end of that population definition. Most of the time in research, the statistical question is at the beginning of it all. Okay, stay there, microphone. First, an example. So suppose in my neighborhood there's a horde of disgustingly gross and annoying finger-biting cats, and I'm trying to find an average weight of all of them. Why am I trying to weigh them? If there are exactly 1,028 neighborhood cats, then the population is 1,028. If I want to get an exact average, I need to weigh all 128 cats. The average weight from this calculation would be a parameter. However, since I'm limited on time and just want to get a good approximation, I might randomly select 20 or so and weigh them, find their average, and this should be a pretty good approximation. The average weight when doing this calculation is called a statistic. With the population, when we calculate a measurement, it's called a parameter. With the sample, when we do this, it's called a statistic. Two of the most used parameters are population mean and population standard deviation, where we'll use the lowercase Greek letters, mu and sigma. Two of the most used statistics are sample mean and sample standard deviation, where we'll use x bar and s. Very often in the discipline of statistics, we use the calculation of statistics to infer information about the population. We do this inference while taking into consideration the uncertainty inherent in random sampling. Let's say we're zoologists and we want to understand the health status of monkeys in zoos compared to monkeys in the wild. The statistical question in this scenario could be, does zoo life have a negative impact on monkey health? The population would be all monkeys in both zoos and the wild. A sample would be just a portion of that population. Subject cases, well, in this example, the monkeys. If we collect data from every subject in a population, then this study is called a census. Variables are the category of values that are recorded from the items of interest. This will mostly be from the samples. A variable for the monkey example could be age, another could be gender, and yet another could be average blood pressure. A random variable is a property of the population that varies from case to case. The difference between a variable and a random variable is subtle and will most certainly become clearer as the course progresses. Having said that, let's try to break the confusion anyways. For one monkey, each of the variables would have only one result. For many monkeys, if a random monkey is chosen, we would get a random result for the variables. Suffice it to say, in statistics, we are almost always referring to random variables. Random variables are broken up into two types. 1, quantitative variables, ones that contain numeric values that you can perform arithmetic on, age, height, weight, etc. Notice that I said perform arithmetic on, i.e., although a US zip code is a number, performing arithmetic on them doesn't make any sense and thus wouldn't be considered a quantitative variable. 2, categorical variable, words, symbols, or numbers indicating category, quality. For example, a color, gender, favorite type of music, and yes, even a zip code. To finish this section off, let's do a quick little check. I want you to very quickly determine which variable type each of the variables I show you belongs to. Thanks for watching. Feel free to leave any questions or comments down in the comments section below. Don't forget to like and subscribe if you're into that sort of thing. In the next video, we're going to cover some more basic and very foundational definitions. Until next time, practice those stats and stay nerdy, my friends.